All right, using mass percentage to determine empirical formulas. There's two types of formulas that we talked about. One is empirical formula. The other one is a molecular formula. Okay. I don't know if you remember the difference, but the empirical formula is the simplest whole number ratio. Simplest whole number ratio. The molecular is the actual formula. Okay. So, for example, let's take hydrogen peroxide. Hydrogen peroxide is H2O2. Okay. This is a molecular formula. Well, how do I know it's a molecular formula? Well, that's because this is not the lowest whole number ratio. The wholest number ratio of H2O2 is HO. Okay, because this is a 1-to-1 ratio. So this is the empirical formula. It's just talking about how many of each atom are there compared to the other atoms. So there's a 1-to-1 ratio of hydrogen to oxygen. All right, so that's the empirical formula. The molecular formula is the actual formula. Sugar, for example, C6H12, this is glucose, actually not sugar. Glucose, this is the formula of glucose. Well, this is a molecular formula. The empirical formula is CH2O. Okay, so that's the empirical formula. By the way, sugars are called carbohydrates. This is kind of off the topic, but it's still chemistry. Why do you think they are called carbohydrates? Well, it's because every sugar is in a ratio of carbon to water. So notice this is C6H12O6. Well, if you break it down, notice it's a carbon to a water. Okay, and it's very common to have carbohydrates as CN to H2ON. So if you have like I don't know, 8, then you have H2O8. So your formula would be, sorry, I'm losing room here, is C8H16O8. And this would be considered a carbohydrate because it's a carbon with a 2-to-1 ratio of water to it. That's why they're called carbohydrates, because every carbon is hydrated with water. That's what makes sugars sugars. All right, kind of off the topic, but yet it's interesting and it's still chemistry related. Okay, so that's the difference between empirical and molecular formula. So what are we doing here? Last slide, I gave you a formula and you had to give me the percentages. In this case, we're giving you the percentages and you have to give me the formula. So we're doing the opposite of what we did in the last slides. Okay, so how do we do this? There's a lot of little secrets and things you have to remember in doing this. Let me erase all this stuff because there's just too much clutter. Actually, you know what? Let me see something. I've been doing this so many times. Is there a way? No, that's just ending it. I'm just wanting, oh, printer options. Let's see. Pointer options. Erase. Erase all. Oh, man. It only took me till 5 chapters to figure that out. Okay, just talking to myself. All right, let's see. The funny part is I bet you some of you are sitting there saying, why don't you just press on it because there's an option to erase, which that's kind of the ironic part. I'm sure there's some of you that already knew that. I don't know why that's there, but oh, there we go. Okay. All right, so where are we here? Okay, so this time, so last slide went from formula to percentage. Here we're going from the percentages to the formula. So how do we do it? First of all, if you have percentages, assume we have a 100-gram sample. Remember, this is all based on mass. So if I have a 100-gram sample, 92.26 grams of it is going to be the carbon, and 7.743 grams of it is going to be hydrogen. So that's kind of what they're showing. These are calculations you do not have to do. I do not know why they waste a slide in doing this for you. If you just see 92.26, just say, well, that's 92.26 grams. If you see 7.743%, that's 7.743 grams. All right. Now everything is based off of moles, mole-to-mole ratios. So what you do is you take the number of grams or the percentage, multiply it by the atomic mass. All right, well, you're multiplying by 1, dividing it by the atomic mass to get a certain number of moles. All right, do the same thing for the hydrogen, you get the same number of moles. What you should get in the habit of, again, your publisher doesn't do it, but what I have found to be successful is you should have at least 5 to 6 numbers after the decimal point. It makes these problems much more accurate. They stop at 3. I would do another 2 to 3 more numbers after this. Okay, so for example, let me just kind of show you. In reality, 92.26 divided by 12.01 equals, I would do 7.68193. Okay, the reason, it might not make sense if you've never done these problems, but you want to get your numbers, which I'll show you in a second, as close, as accurate as possible. So this is 7.281547. Okay. So this is what I would actually do. I would do 5 to 6 numbers after the decimal point. All right. So basically, why do we do this? Because remember, mole to mole ratios tell you how many atoms of each you have. All right. Like we saw in the water example, it's 2 moles to 1 mole. All right. This number here is telling me how many moles. Well, I have these in moles. Well, how do I get these into whole numbers? What you do is you divide by the smallest number. In my case, the smallest number happens to be the 7.68154. So divide by 7.681547, which equals 1. Divide this by 7.68193, and you also get 1. So it's a 1-to-1 ratio. So your formula is CH. Okay? So it shows you it's a 1-to-1 formula. So this is your empirical formula. So do I know the actual formula? No. It could be C6H6, could be C8H8, could be C3H3, could be C10000H10000. All right, I don't know what the actual formula is, but I know it's a 1-to-1 ratio of some sort. Okay? So this is how you do these problems. This might be a little more confusing because I'm changing a little bit than what the slides have, what the publisher has, but I'm not changing it a lot, okay? It's basically the same approach. Take whatever percentage you have and make it into grams. Divide it by the atomic mass, okay? And then you're going to get some mole numbers. Divide by the smallest and find out what the ratio is, okay? So here's another example. Let's say you have 53.31% to 11.19% to 39.51%. So that means I have 53.31 grams of carbon, 11.19 grams of hydrogen, and 35.51 grams of oxygen. Okay, do all the same thing. So you get 4.439. Again, I would get more numbers afterwards. Okay, they are giving you pretty good numbers so that you don't have to worry about it. All right. And then I would, again, do more numbers after this, but it's okay for right now. All right, find the smallest number. What's my smallest number? 2.219. Divide everything by 2.219. 2.219. Okay, so what do you get? I have my calculator right here, so I will do this. 4.439 divided by 2.219. I get exactly 2.000. So that is 2. All right. 11.10 divided by 2.219, I get exactly 5.0, and then 2.219 divided by 2.219, I don't need to type that in my calculator. That equals 1. So it's a 2 to 5 to 1 ratio, so the formula is C2H50. Notice they're doing the division right here, okay? This is ridiculous. Again, things your publisher does I find kind of funny. You don't have to write it like this. I mean, come on, write it like the actual formula. Just find the numbers and write the formula, okay? There are a few more problems here. There are some things I do want to talk about. Let me talk about on this page. Sometimes when you do this part of it, when you do the division part of it, you don't get exact numbers. You don't get exactly 1.00. There are 3 possible answers you'll get. You'll get some number with 0.50. Okay, so you might get like 1.50 as a number. Okay, well, you can't have a fraction of an atom. So you need to multiply this by the lowest number until it gives you a whole number, which would be the number 2, which gives you 3. So if you were to get a carbon that equals 1 and a hydrogen that equals 1.5, you have to multiply everything by the number 2 so that you get whole numbers. So your formula would be C2H3. Okay? I hope that makes sense. So in this case, everything came out to be zeros at the end. Okay, but sometimes these don't come out to be zeros. They could be 1.5 instead. If it's 1.5, everything gets multiplied by the number 2. Okay, the other option is you might have a number with 3, 3, 3, 3, so forth and so on after it. Well, if this happens, let's say you get 1.333, what number would you multiply to get the next highest number? Well, that would be 3. It gives you basically 3.99999, which is 4. Okay, so if you get, a 1 to 2 to 1.333, okay, so carbon is this, hydrogen is this, oxygen is this, you got to multiply everything by the number 3. Okay, so you get C3H6O4. All right, and then finally, the last possibility is you'll get 0.25. You'll get some sort of number with a 0.25. In this case, you multiply by the number 4. Okay, so if you get 1.25, multiply by 4 to give you 5. Okay, so that's what you might have to do. All right, why don't you go ahead and do this problem and come back and let's see what happens. Welcome back. If that was too fast, make sure you pause it and do it again. Okay, so here we go. So they're converting everything to grams. You do not have to do these calculations. You can just simply take this percentage and just put a gram there and put a gram there, put a gram there. Kind of a waste of space right there. Okay, so here we go. We get a 3.3123, a 2.500, and a 3.740. You divide by the smallest number. In this case, it's 2.5. So you notice they're dividing everything by 2.5. And what do you get? Notice you get a 1.25 as one of your answers, a 1.0, and a 1.5. In this case, you get kind of a little bit of everything. All right, so you have to find one number that you multiply all these by to get a whole number. Well, if I multiply this by 2 and multiply this by 2, I still don't have a whole number. So I have to multiply everything by the number 4. They all go into number 4. So this will give you a 5, this will give you a 4, all right? And this will give you a 6. Does that make sense? All right, notice what my fractions came out to be. So my formula is C5H4O6. I hope you got this. Like I said, if you didn't, we will do a lot more problems in class. Okay, so pause there and we'll come back with the very last section of 5.5, talking about molecular formulas.